Hello again. I'm Mark. Sometimes we're really restricted on having the equipment we want. Especially right now, there's a blizzard going on outside. You can't get to wherever, and it's like I need a sine wave for something. Maybe not a very high frequency. Maybe just in the audio range. And the AOScope program does great with square waves, but it doesn't have an analog sinusoid output. Well, by adding one part, something called a Max 7426. This is a let me it's a fifth order low pass elliptical switch capacitor filter, which does what? It gets rid of higher frequencies. It's a low pass filter, so we can get rid of the high stuff, let the low stuff pass through. Now, for something you haven't quite had yet, or most likely have not, is when I give a square wave, you can think of a square wave as being a sum of a whole bunch of sine waves. And the lowest frequency sine wave is going to be the biggest magnitude, and they're all going to be odd harmonics of it. So if I have a 100 hertz square wave, there'll be a 100 hertz sinusoid, a 300 hertz sinusoid, a 500 hertz, a 700 hertz, 900, and they just go on up forever if the square wave is perfect. Nothing is. But okay, if I get rid of all those higher harmonics, I get a sine wave. So if I take this chip and I stick it on my AOScope program, I can get a sine wave. So let's get that to work. Okay, first of all, let's go back to document camera. Okay, so I've got my part, and I'm going to stick it in here. Okay, there's a pin 1. There's stuff like that. I'm just going to stuff this in here. Okay. So pin 1 is on the left, and I need to figure out how I'm going to connect this thing. Let's see if I can get everybody on here at once. Okay, so here's my pinout that I need. So up in here, it says pin 1 is COM, pin 2 is in, pin 3 is ground, pin 4 is VDD. Okay, so ground, I got that. Okay, so if I take a jumper and I connect it between pin 3 and ground. So in here, I'll go from pin 3 to ground. Okay, I know that's small. Let's see if we can get this a little bit better. Okay. Now, notice that I'm unplugged here, so I don't have any power going, so nothing's going to blow up on me if I do a mistake. I'll just want to make sure everything's right. Okay, so in the next wire I need, pin 4 is VDD, so we need pin 4 to be power. So let me grab that. Okay, pin 4, and let me connect it to that bus bar. I've already got the power and ground from my Arduino connected to these bus bars, and I just use these little short wires because they stay out of the way a lot better. Okay, so there's that. Now, if I look at the recommended circuit here off to the side over here, my ground is here. I need a capacitor to... I need the OS and COM have to connect together, and I want to cap to ground. Well, OS is 6, COM is 1, and I bet this cap is big enough. If I could put it between pins 3 and pin 1, that's the ground already for me. So I'll just put that in here between pins 3 and 1. So now I just need to connect the other side of, I need to connect COM to OS. So that's pin 1 to pin 6. So that's pin 1. And I need to get that to 6. So that's 1, 2, 3, 4. On the other side's 5, 6. Okay, so that's connected. Now what else do I need? Let's see. I've got the VDD to shut down bar. Okay, so that's shut down SHDN. Needs to be connected to VDD. That's pin 7 needs to connect to pin 4. So let me grab another jumper here and connect pin 4 to pin 7. I know it gets messy with all the wires in the air. Okay. So that's now there. Okay, so what do we have left? We have in, clock, and out. Everything else is ready to roll. So we have in. So what do we get our square wave from? You know, our best, most accurate clock is clock A from our Arduino, or for the AOScope program. So clock A is on D10. So I want the D10 is my input. So a wire to D10, there's 9, there is 10. And that goes to input, which is on pin 2. So if I run that over here and put that in on pin 2. Okay. I've still got 2 left. I got the clock in the output. What's the clock? The clock actually determines our cutoff frequency. So I need an adjustable clock. So we're going to use clock B for that. And the way the program's set up, you have to use clock A and clock B, as I've said here. So clock B, if I go down here, here says clock B output is on D5. So if I come over here to D5, okay, so there's my D5, and it needs to connect into my clock here, which is pin 8. That's the last pin in the corner here. Okay. So now all I have is my output. And what do we want for an output? Well, the output actually, we want to go look at what it's doing. So what we want is we want to feed it back into A0. Because A0 is going to be what we can look at. That's the oscilloscope input. So that makes sense. So let's go from the output, which is on pin 5, and nothing's connected to that yet. Okay. And I want to connect that to my A0 line, and I have no idea where I put that. Okay, A0 is clear over there. Okay, so let me run this over to that's 2, that's A1, here is A0. Okay, so everything should be connected. Let me just plug this back in. No smoke. Okay, that's a good sign. Now let me go back to my AOScope program. It's already uploaded. I don't have to re-upload it again. Let's see, serial plotter. Okay, that display is kind of in the way, so let me just go to that. Okay, so it's already set to carriage return that. Let me just hit the send. And there's nothing there. Well, we really haven't told it to put anything there yet. So let me set the clock output. We've got a special command for when we're doing SineWave, which is CS for SineWave, and then F, and we can, it's the example here is CF200, we'll set the sine wave to 200. Let's just go for that. So if I say CSF200 and hit return, and then another return, we've got a sine wave. Oh, there's the 2 waves again, because remember, you know, we get that occasionally where that input A1 is floating, and so it kind of follows along. I'm going to put a wire between the A1 line and ground. And then we hit another return. Okay. So there's a 200 hertz sine wave. Let's go a little lower in frequencies. CSF, let's go for 50 hertz. You have to hit a second return. Did I get that right? It did not. CSF 50. I must have mistyped something before. There we go. Okay, there's a 50 hertz one. You can see a little bit of jaggedness in it, but you know, that's not bad. If I want to adjust the amplitude down a little bit, because I mean that's really close to the limits of our 5 volts, I can actually do it by changing the cutoff frequency, which is the clock B. If I look at the top up here, it's saying clock B is at 4.8 kilohertz. if I change clock B frequency to 4 point, just a little bit less, 4.6 uppercase K, remember it's K. You can see by just reducing the value, the frequency, just a little bit, our amplitude goes down a lot. So we can actually control our amplitude even with this a little bit. So we get a sinusoid output. Remember, the microprocessor is 0 to 5 volts. So the sinusoid is not going plus and minus. It's actually centered around 2.5. Now we could take the trigger. Well, let me just do that. Let's say I want the trigger source to be 0 because I want it to be the channel, the sinusoid. And I want the source to be at 2.5 volts is where I want it to trigger, and I want to trigger it rising. So I could say trigger T rising. I need it millivolts, 2500. Now when I hit a return, there's my 2.5 volt line. So we can actually see it. And you can see in our program, here's my trigger point is right here. And that coincides with the voltage going up, as I said, rising at that particular voltage. If I wanted trigger falling at that same point, I could say TF, trigger falling, and then hit another return so it triggers again, and here it is for this. Now I can feed this sinusoid into some other electronics, and then feed that back into A1, and then you can see the difference between whatever your signal did. For those that have played with the Fourier transform stuff, if I say F1 and say I want to do a Fourier transform of it, it just gives you a sharp spike. And it's saying that the spike is at 39 hertz. Those frequencies are way off. Let me get up the frequency up quite a bit. CSF 1K. We're going to go for 1 kilohertz. And let's see what that does. Okay, it moves the spike. But there's not very much other noise there, so it's actually doing pretty good. Let's take that up. CSF 2K. There's a 2 kilohertz sinusoid. And it looks really good in the frequency domain. If I go back to F0, you can see that it'd be really nice if the scope sampled faster. But sorry, we're at the limit. We're at 10,000 samples per second, and there's nothing I can do to make it faster than that with an Arduino running at this speed. At least not that's going to fit in this amount of memory. Okay, that's all I wanted to show you is how to get a sine wave out of this thing. And we'll go from there.